In this section, we will see the complications that arise from deploying a large number of services and look at the common solutions to the problems. In this video, we will look at some methods for dealing with deployment of such a system. Containers are the choice method of deployment for microservices today. They are a sort of sandbox surrounding one or more processes and providing an internal file system, resource limits, and user management. You can think of a container as a small biosphere, which includes a single plant and all that it needs in order to grow. Yet, it blocks it from all access to the surrounding environment. Containers similarly limit their contained processes on CPU and memory consumption, as well as permission restrictions. Containers can be saved to images in a way that is similar to virtual machines. And since container images already hold everything that is needed to run your service, they are ideal as a vessel for shipping. Container images provide a consistent environment, holding the exact versions of binaries, assets, and dependencies that the service needs, along with a minimal environment that makes them harder to attack when properly secured. Docker is the most frequently used open source for containers, but most of you already know that. The host OS is typically Linux, since Mac OS has no support for containers, and although Windows containers were released, they are still bulky, extremely undocumented, and are hard to connect to networks. In order to be useful, containers need to communicate. They can get input by environmental variable injection or file system mounts, and they can be allowed to listen to ports by creating a port mapping from the host computer ports to the one inside the container. Containers are very lightweight in contrast to virtual machines, since they share the OS kernel and incur almost unnoticeable overhead on the processes they run. When working with microservices, containers get numerous fast. It is common to have between tens and hundreds of service types and run several instances of each. Such systems require constant tracking, monitoring, upgrading, and redistribution of their containers across machines and availability zones. That is why we have container management systems. Management systems have responsibility of running containers on machines, managing machine scaling, recycling failed containers, upgrading by dropping old containers and swapping the new versions, introducing service discovery information into containers, and more. In this area, Kubernetes is the most widely adopted, with all major cloud vendors providing managed versions of it. There are also others like Docker Swarm, Mesos, and AWS homegrown Elastic Container Service. For managing several containers on a single machine, the simplest method is by using Docker Compose, which is what we will see in the sample. Let's see the code. Okay, so in order to get everything Dockerized, we need to create Docker file for each image. A Docker file is basically a file containing the commands on how to build the image and what to put inside it. So here we start from Node.js Slim Docker, which is taken from Docker Hub Online, and that already holds Node.js and some version of Linux. Then I'm creating some directories, installing TypeScript, copying my files into it, running npm install to get all of the dependencies. Then I'm copying in the source and letting gulp do its work. After that, I'm using multi-stage build, so I have another stage, and this stage also starts from the same base container. And what it basically does, it copies over all of the build artifacts, all of the binaries, or my build JavaScript. So I have a clean image with only the artifacts I need in order to run. So after copying everything in, npm install all the dependencies again on the clean image, and then I expose port 3000 since this is the song service, and then I enter a command that will run when the Docker starts. So I did the same for the playlist, and that is very similar. Router is a bit different. So here I start from an Nginx image, and then I copy over the configuration that I made. This can be mounted, but since I'm working with the Windows Docker, that will be kind of hard-coded paths, so I don't do that. And then I expose the port, and I also have a command for Nginx. And front end has a similar Docker file that uses Vue.js CLI in order to compile, and that uses Webpack in order to create single JavaScript and package everything. And then I run node static in order to serve it. Okay, so if I want to run this, I'll just go to command line. Okay, and let's say I want to build songs. So in order to build songs, I'll run docker build here -t, and I'll give it a name, songs. And now I'm running the build process. It will pick up the Docker file from the directory it's currently in and start running the commands. Okay, you can see that everything here is already cached since I already ran this build. And I can look at my images and see that I have the different images here, and the image I've built right now is this song's images. And since it hasn't been changed, didn't update, and it was already built 2 hours ago. Okay, so in order to run this, I created a Docker Compose file. And Docker Compose is basically composing, or it's running a lot of different services together and different images, and it's injecting everything that run these images into these Docker containers. So here I'm running the songs image. I'm mapping the port to the outside port. I have a restart directive. I have depends, so this will not run until Mongo is up. I have front end image already mapping the port, saying it depends on songs and playlists, and then so on. So playlist, Mongo Express is the UI I use to look inside Mongo. Then I have the Nginx in order to route everything. And I also have some stuff here that can be used in future videos. So I have Redis for caching and etcd for configuration. So if we'll open up Firefox, and I already ran the Docker Compose. So in order to run Docker Compose, you could just run Docker Compose up. And if you want to detach it, you press -d, and that will run all of these containers. And if you don't do the -d, you'll see something like this. And if we go to Firefox, localhost 3080, which is our Nginx router, then we can see the application since the UI is in the home directory, and we can interact with it the same way we did until now. It seems to be working. Okay, so that's it for Dockerization.